So there are some special triangles that we need to figure out, and the first one's going to be a 45, 45, 90 degree triangle. So we take a square and we draw a diagonal. It splits the square into two triangles, and we know that squares have right angles, so therefore it makes two right triangles. This was originally 90 degrees. Half of that is 45. So you have your 45, 45, 90 degree triangle, and you have a shortcut that when you have a square of side length 1, so this is 1, this is 1, these two red lines would be 1, you use the Pythagorean theorem and get root 2 for your hypotenuse. We also have a 30, 60, 90 triangle. We have the equilateral triangle, and we draw the perpendicular bisector from the top down to the base. And so it creates a right angle here. If this was originally an equilateral triangle, that makes this 60 degrees, 60 and 90, so that means this one up here is 30 degrees. Equilateral triangles would all have side length 2. This is side length 2, so half of it would be 1, and using Pythagorean theorem, this would make it root 3. So we can use these special triangles and create a table of values of the trigonometric ratios for special angles. So for 30 degrees, that in radians would be pi over 6, using the formula that we used in 6.1. Taking the sine of theta will give you 1/2. You can refer back up to your special triangles. Cosine be root 3 over 2. Tangent will be root 3 over 3. Cosecant will be 2, the inverse of sine. Secant is the inverse of cosine, so you have to rationalize the denominator. Get 2 root 3 over 3. And then cotangent, it's the reciprocal of tangent, so it goes to 3 over root 3. Have to rationalize the denominator, and it goes down to just root 3. 45 degrees comes next. 45 degrees is pi over 4 in radians. If you look at your special triangle, sine is going to be the same as your cosine, so they are both root 2 over 2. Your tangent, opposite over adjacent, 2 over 2, goes down to 1. That makes the cotangent 1. And secant and cosecant are known to be the same. They are both the reciprocal of root 2 over 2. Have to rationalize the denominator, and you get out root 2. Then you have 60 degrees. Convert it to radians, get pi over 3. The sine of it goes to root 3 over 2. cosine is 1/2. It's just switched from 30 degrees. So tangent goes to root 3 because it would be 3 over root 3. Rationalize the denominator. The cosecant is going to be the reciprocal of root 3 over 2. Rationalize the denominator, 2 root 3 over 2. So it's the secant down, so that means cosecant will be 2, and cotangent is root 3 over 3. We talked about this in the last chapter, but please remember the reciprocal relations. Cosecant of t or theta or alpha, whatever angle it is 1 over the sine. Secant of the angle is 1 over the cosine of the angle. Cotangent of the angle is 1 over tangent of the angle. Those are important to remember. Okay, so when we want to find trigonometric ratios, you're either going to be given it in degrees or sines, and it matters which one they give it to you in because you have to plug it into your calculator correctly. So if we're given the sine of 1 and it's 1 degree, you have to make sure your calculator is in degree mode. If you don't know how to change it or check, please let me know in class and we can go over that together. So you just plug in sine of 1, and it is approximately 0.0174524. So 0.017. You have to then switch it to radian mode and plug in the sine of 1. And it's going to be bigger because 1 radian is much bigger than 1 degree. It gets out 0.841471. So use those. And let's say that these are both given to you in degrees. Plug in the sine of 17. Make sure you are in degrees. Let's round to 3 decimal places. 0.292. For secant of 88 degrees, there is no secant button. That's why the reciprocal relationships come into play, and they are very important. It is 1 over the cosine of 88 degrees. So in your calculator, you need to plug in 1 divided by cosine of 88. And you will get out 28.654 if we round to decimal places. 3 decimal places. Now let's switch over to radians. All you have to do is plug in the cosine of 1.2. Let's round to 3 decimal places. You get 0.362. The cotangent, we don't have a cotangent button, so you have to go 1 over the tangent of 1.54. 1 divided by the tangent of 1.54 is 0.0308. So a triangle has 6 parts. It has 3 angles and 3 sides. So when you solve a triangle, that means you know all 3 sides and all 3 angles. So we have this right triangle ABC. We're told angle A is 30 degrees and the hypotenuse is 12, and let's just say it's, we don't need a unit. So we have to find 2 angles and 2 side lengths. We cannot use Pythagorean theorem yet because we only know 1 side length. We must know 2. So figure out the other angle. This is 90, 30, this is a 30, 60, 90. So this is 60 degrees. So to find A, it is opposite the 30 degrees, and we know the hypotenuse. So we can take the sine of 30 and gives us A over 12. Remember, SOHCAHTOA. So we are using SOH. SOH. So to work this out, we have to solve for A. Multiply by 12. You take 12 times the sine of 30 degrees. You can typically plug this all into your calculator at once, or you can use that nice chart that we made and know that the sine of 30 degrees is 1/2. To get 12 times 1/2, A is 6. So now we can figure out B 2 different ways. We could either use Pythagorean theorem or we could use the cosine. So since we're doing trig functions, let's do the cosine. The cosine of 30 degrees so you have your adjacent B over 12. So 12 cosine of 30 degrees equals B. Cosine of 30 degrees is √3 over 2, which you know from your chart. Work it out to get B. B goes to 6√3. So we can generalize this example, and we have angle theta. The like opposite angle theta, A, is the hypotenuse R times the sine of theta. Leg B is the hypotenuse times the cosine of theta.